Hello, this is a video on the divisibility tests. I have a handout where we have the divisibility tests up to 10. Let's take a look at our handout. You probably know the divisibility test for 5. Here it is. The last number needs to be a 5 or a 0. For example, 12,390 is divisible by 5 because it ends in a 0. 3,475 is divisible by 5 because it ends in 5. You probably also know the divisibility test for 10, which is at the bottom of our list. If it ends in a 0, then it's divisible by 10. Now let's do 2, 4, and 8. You probably also know the divisibility test for 2. We look at the last digit. If the last digit is even, then the entire number is even. The entire number is divisible by 2. What I'd like to do now is go to the divisibility test for 4. Here it is. The last 2 digits form a number that's divisible by 4. So you look at the last 2 digits and treat it as a 2-digit number. 4,524. We look at the 24. 24 is divisible by 4. Therefore, the entire number is divisible by 4. Let's review our notation. 4 divides evenly into 24 is written with the vertical line. 4 divides 24 implies that 4 also divides 4,524. Both of these are true statements. Divisibility test for 2, you look at the last digit. Divisibility test for 4, you look at the last 2 digits. The divisibility test for 8, you look at the last 3 digits. If the last 3 digits, treated as a 3-digit number, is divisible by 8, the entire number, no matter how big it is going to be divisible by 8. In our example, we have 1,816. 816 is divisible by 8. Therefore, 1,816 is divisible by 8. These divisibility tests give us a way of easily determining if a number divides into the number without doing the long division. I hope you're noticing a pattern. 2 to the first, use 1 digit. 2 to the second, use 2 digits. 2 to the third, use 3 digits. So probably if you wanted a divisibility test for 16, you'd look at the last 4 digits and see if it's divisible by 16. That might be a little impractical in your head. Okay, the next 2 divisibility tests I'd like to look at are 3 and 9. They work in similar manners to each other. What we do is we take the individual digits and we add them up. The sum of the digits is divisible by 3 will mean the entire number is divisible by 3. The example on our handout is 123. 1 plus 2 plus 3 is 6. 6 is divisible by 3. Therefore, 123 is divisible by 3. The divisibility test for 9 works the same way. We add up the digits and we look at the sum and we see if the sum is divisible by 9. Let's do a couple of true-false questions. Our first true-false question is 3 divides evenly into 76,044. Pause the video and see if you think that that is true or false using the divisibility test. This is true because I take the digits 7 plus 6 plus 0 plus 4 plus 4. That equals 21. 3 does divide 21, so therefore 3 is going to divide the whole thing. This is true. Let's take a look at the next example. Let's say we have 9 divides 2,855. Pause the video and determine if that's true or false. This is false, because if we add up the digits 2, 8, 5, and 5, we get 20. 9 does not divide 20. Therefore, 9 does not divide the whole thing. This is false. Let's return to our handout. The divisibility test for 6. In order to be divisible by 6, the number needs to be divisible by both 2 and 3. So we apply the divisibility test for 2, which means it has to be even, and the divisibility test for 3. And if 2 and 3 both divide in evenly, 6 will also. There's also a divisibility test for 7. And I'm not going to really take time in this video to go over that one. I will let you study that on your own. The good news is for the divisibility test for 7 is if you have a huge number, you can use the divisibility test repeatedly to get to something small. Now let's go to some more examples. You might pause the video and see if 1, 2, or 3 are going to be true or false. Number 1 is true because the last number is 4, which is an even number. Question 2 is false because it does not end in 0. And question 3 is true because 7 and 4 and 7 is 18, and 9 divides into 18. Now I'd like to do some examples that are similar to our textbook. Let's take a look at item 6. The way this book asks the question for number 6 is fill in the following blanks with the greatest digit that makes each statement true. So we're going to be putting a digit in there to make it true. The way I often like to ask the question is fill in the blank with all the digits that make the statement true. So let's go back to our examples. My directions are slightly different than the book. State all the numbers that go in the blank to make the statement a true statement. The answer will be one digit positive. The answers will be one digit positive answers. There may be more than one answer and there may be no answer at all. So question number 1. 4 divides evenly into 730 something. So we have to think about and apply our divisibility test for 4. 4 needs to divide 30 something. So our candidates are 30, 31, 32, 33, 34, up through 39. Well, 4 does divide into 32, so 2 would make that a true statement. What other numbers in the 30s are divisible by 4? 36 is divisible by 4, so 6 can go in the blank and make a true statement. This is the answer to number 1. Now let's look at number 2. 9 is going to be a divisor of 7,650 something. The divisibility test for 9 says we need to add up the digits. So we have 7 plus 6, which is 13, plus 5, which is 18. 18 plus the last digit needs to be divisible by 9. Well, it could be 0. 18 plus 0 is 18. That's good. That works. But what about the other numbers 1 through 9? Will any of those work? Yes. If the blank is a 9, now the sum of the digits would be 27. 9 divides evenly into 27, so 9 divides into 7,659. Our last example today is 6 divides 500 something 1. And we want to find the digit or digits that makes the statement true. In order to be divisible by 6, it must be divisible by 2 and 3. We could force this to be divisible by 3, but we are not going to be able to force this to be divisible by 2 because it ends in an odd number. There's no way that 2 is going to divide that number. So therefore, 6 is not going to divide the answer. 6 is not going to divide the number. So the answer is none or no numbers. This has been a video on the divisibility tests. I hope you find this useful. Have a great day.